So, welcome back. It's time to start now. Okay. So those were three really illuminating talks, and just to help frame the discussion a little bit, maybe in a way that's skewed a little towards my own interests, possibly. But I'll just pose a few mostly general questions to help frame the discussion. But don't feel obliged to of course, don't feel obliged to follow these particular questions. So one question I had, I think these are all themes that I think they were touched upon in all three of the talks that we heard. So one general question I had is, to what extent is the distinction between relative facts and experimental context or assessment context? To what extent is this a terminological dispute rather than a substantive issue? So some answers were coming out during the talks, but I wonder if we could flesh this out a little bit further on the three views with respect to the three presentations that we heard. Another issue, I think, a slightly more general issue is the question of how objective should we take science to be, or how objective should science be? There's another way of putting that. So is it all right, for instance, for the concept of observation, even in a very minimalistic schematic sense? Is it all right for that to be involved in the interpretation of a theory? Or is it the case that we must exercise the concept of observation, even in a very schematic sense, from physical theory, completely? And even more general than that, I have further questions. How, generally speaking, should we understand the relation between the concept of objectivity and physical theory in general? So this was partly coming out in the way that Czaslaw, in his presentation, put objectivity, the word in scare quotes. So I'm to get some inspiration from Chris's conducting session yesterday. I'll point out what I think it's a very loose analogy, but I think it's somewhat apt historical analogy. So Poincaré famously thought that our concept of geometry should be settled first before we move on to understanding physical theory. And so famously for Poincaré, he focused on geometries of constant curvature, and he picked out Euclidean geometry as the simplest. And so in that context, in the face of modern physics, the question is, how should we revise the dynamical laws of our physical theories in order to make them conformant to Euclidean geometry? So I'm not a Poincaré scholar, but I want to point out this general fact. And I wonder to what extent that analogy can even be extended to the concept of objectivity itself. So is what we mean by the concept of objectivity, so do we mean a so-called view from nowhere, a concept of objectivity where we completely write the observer out of the description of our physical theories? Is that the concept that we should take a priori and then seek for our physical theories to conform to? Or should we take the very concept of objectivity to be informed by physical theory itself? And in particular, I think this is an issue that really comes to the fore in discussions of quantum mechanics. A slightly more specific question, and this is partly in relation to Andrea's talk. So when he presented the motivations for relational quantum mechanics, there were two bullet points up there, if I recall correctly. One of them was participatory realism, and the other was naturalism. And so participatory realism is a term that many of you will find familiar from Cubism or from people who defend views of that sort. And that seems prima facie to be in tension with this naturalist idea. And so I was wondering if that might be a question that we could flesh out a little bit further in the discussion period. Another question is, so what do we require in order to define and to formulate an experimental context? So this was brought out, this was fleshed out in the three talks, of course, but it's something that perhaps is worth a bit more discussion, a bit more fleshing out during the discussion period. And in particular, how do we define, and this is more specifically directed to Richard's talk, how do we define an assessment context across multiple observers? And finally, another general question is, what role do no-go theorems play in the methodology, or what role should they play in the methodology of theoretical physics? And I'll end there, and I'll open the floor. Emily?
Hi, yeah, I had a question specifically for Čáslav, but also for all of you, because you all sort of used this notion of a objectivity bubble of some kind. So I take it the idea is that the objectivity bubble defines kind of a shared context within which we can have intersubjective agreement. And I guess I wanted to know a little bit more about how this intersubjective agreement is supposed to come about. The idea seems to be that decoherence brings about the intersubjective agreement, but I find that a bit puzzling because, I mean, decoherence only separates out distinct measurement outcomes. It doesn't select a single one. And so there doesn't really seem to be any obvious way to have a mechanism for which observers inside a bubble can come to agree on a single outcome, even if they are all in the same decoherence context. And indeed, there doesn't seem to be any mechanism in pure unitary quantum mechanics which can do this. So I sort of wondered, how is this intersubjective agreement supposed to be secured in this kind of picture?
I think that was a question for Richard.
Čáslav, but
for
also
Čáslav, sorry.
Richard if he wants.
So Čáslav, is that Čáslav? There's a finger in the back there, and Richard afterwards.
I guess this problem doesn't exist in practice because people that do the experiment together, they are sure that they saw the same outcome and they communicate them to other people and publish the papers and everybody agrees. But you can ask how we can derive this from the quantum theory, and I would not seek to derive this from quantum theory because I believe the quantum theory is deals with irreducible probabilities. If I would be able to give you a reason why we get one out of many outcomes, that will be a hidden variable, even deterministic theory. I'm not seeking for that.
Richard had a finger. So I just, I forgot to mention that we'll follow the convention that we have been up until now, just a finger for a follow-up to the question that was just asked, and a hand for a separate question. Richard? Richard first, and then Carlo, and then another question there.
I take it that there are two steps to securing intersubjective agreement. There's the within bubble step, and then there's the when the bubble is burst step. As for the within bubble step, I would appeal to the kind of results that Zurek and his followers have come up with regarding decoherence, how decoherence can be spread widely amongst a number of quote-unquote observers inside the bubble. To the extent that that program fails, then that's trouble for my account. But it's not work that I, as a philosopher, feel competent to be doing. I leave that to more capable hands and wish them good luck. When you come out of the bubble, things are more interesting. I mean, I take it that the no-go theorems that are available today show that there is no consistent truth assignment for the observation reports of everyone in every bubble, as it were. So when the bubbles merge, all we're looking for is a subsequent agreement, and realize that's not such a desperate situation to be in, because in the Bong scenario, for example, Charlie and Debbie eventually emerge from their own little bubbles, but when that happens, the entire contents of the lab have been unitarily reversed. So you wouldn't expect them at that point to be voicing opinions corresponding to what they actually experienced when they were inside the bubble. They'd probably be rather dazed. It's not a nice thing to do to your friends. But there's no reason to suspect that they will disagree with what Alice or respectively Bob say afterwards. So any reported, observed outcome inside a bubble becomes essentially irrelevant afterwards when they all come to share the same context. And from my point of view, sharing the same context at that stage means being now in the same decoherence environment. That's how the answer is supposed to go. But again, I'm relying on this notion of decoherence And from what I've said today, it's just this magic wand, right? In fact, it is a very detailed physical process for which we have all kinds of models. In the end, it's whether those models can adequately deliver the goods to back up the story I'm telling.
Did you have a reply? Did you want to say something in reply, or?
Yeah, I just think my concern is that decoherence on its own is not enough to bring about intersubjective agreement, because decoherence doesn't select any outcome, and therefore it also doesn't provide any mechanism to say that you and I will share the same outcomes even though we're in the same decoherence environment. So it seems to me that something does need to be added to that account to bring about the additional requirement that we're going to share some common outcomes of some kind.
Carlo had a finger?
I want to make a comment, but in practice, a comment about in principle. In practice, of course, we are in the common decoherence environment. There's this huge world around us where information gets lost everywhere. And therefore, of course, we have a common context in the sense of Richard. But it seems to me that that was observed already at the beginning of quantum mechanics, when the first discussions in the 30s about objectivity came about. And the standard answer was, there's a classical world, and the classical world in some sense emerged from quantum mechanics. Now understand how, thanks to the coherence, it emerged, so that we're all in that. And that's largely sufficient in some practical sense to guarantee the objectivity of science in the weak sense. It seems to me. We're facts, we share this fact, that's what we mean by that. So I don't see a big challenge practically to the practice of science. Now, theoretically, it's much more interesting, because of course now one can put oneself in this hypothetical situation in which, Richard, you indicated. Well, suppose in the future we can actually put not just a few qubits, but a full human being thinking. Would that challenge the coherence of science? It seems to me we're missing a point here. And that's the main point I want to make. Physics is not geography. It's a different kind of things. It's not a list of facts about the world that happen to be universally true. Classical physics has never been like that. Physics is a model knowledge about the world. It's formulated in a model way. Physics is a phase space, and it's some equations of motion, or a Hilbert space, or some dynamics, or some whatever generalization of that. So it's always in the form if this, then that. The content of the principle is that if you have put this initial condition, then there are these forces, and then what happened. So I don't understand where is the challenge of objectivity of physics, of this knowledge about the world that comes from the fact that there are facts relative to me, in principle, even supposing being so smart to circumvent the coherence, could be different than the fact relative to you. Because imagine you have a room, okay? I go inside and I see a red light, a green light, red light, green light. So I come out and say, okay, I got the law of physics of that. Every green light follows a red light, every red light follows a green light. And then you go in and you see the same, and he goes in and say the same. And of course we can communicate, because nothing in the relativity of facts excludes the fact that we can communicate. So we all agree that there are the same laws of physics, we all agree, and I know that you might have some experience that I don't have. So what? This is our experience in life, that each one has experience. Whether we are in different places or in different context, the coherence context, I don't see any challenge of the foundation of physics. The fact that there might be different coherent contexts in which we can be.
I mean, to clarify the comment I opened with, I didn't mean to say there's a challenge to the foundation of physics.
I did.
Okay, right. So maybe Richard can respond now.
Yeah, I would like to.
So Chester.
Sorry. I would just like to complete my reply for Emily because I didn't understand what she asked. Now she clarified a bit more to me. So I would say that one way to see that there is agreement between observers is to take description from outside, let's say from Wigner, and put many observers in the lab. And I think what you will then get is the again entangled state between all observers seeing spin up, or and spin being up, plus all observers seeing down and spin being down. You will never see that some observers see something different. So this can explain why they all see the same thing. But of course, again, I would not go and seek for explanation why they all see one particular event, because this will be a hidden variable program.
Okay, let's move on to someone else first. So we had a question right here. I don't know your name. I'm sorry.
Yeah, I'm Zach.
Okay.
I just wanted to try to work in some perspective, I think, from one of the founders of quantum field theory, of quantum theory, that's Niels Bohr, that I think is along the line Chaslov was indicating in terms of this issue of objectivity in relation to quantum theory. So specifically with the question of intersubjective agreement vis-a-vis objectivity, I take it that Bohr's way of looking at things is basically to reverse the direction of reasoning of Richard Healy's, that, well, if you have multiple contexts relative to which your experiments come out in certain ways, then you have a threat to objectivity. But what are we doing as scientists? We're committed to the ideal of objectivity. So we're now committed to only conducting experiments and reporting results in contexts we make intersubjectively shareable. And that's the only way you can make the terms in your physical theory have some sort of objective reference, at least from the perspective of an experimentalist. I mean, this perspective is probably not that satisfying to those who maybe are wondering how does cosmology or something like this fit into the picture. But anyway, I think it's just an interesting perspective to have on the table, that there's, in some sense, a way you can look at things where it's not really a mystery where intersubjective agreement comes from. It's something you're committed to doing, committed to finding only those experimental arrangements that you can communicate to any other human being. And then I guess you can feasibly assume that anyone who is in the same experimental setup would have the same determinate measurement records. But to me, it doesn't seem like a meaningful question to be, or a meaningful skeptical worry to think other people might have other observations of what the determinate measurement outcomes would be in other situations, because it's not the same situation. So anyway, I just wanted to offer that broad spirit of a way you can respond to this issue of objectivity with respect to quantum mechanics.
Did anybody have a finger specifically directed to this comment? Richard?
I have 3 fingers on the previous 3.
Okay, Richard, then Wayne.
Okay. I'll start off with Emily. Emily, I think there's an issue that you're still probably dissatisfied with. Where does this, how does decoherence itself secure a definite outcome? And how does it secure the same definite outcome for 2 people within a bubble? It doesn't. This is a further assumption. It's analogous to your interperspective, whatever the principle was. But it's an extension of the same game you're playing. You're playing it twice. The first move in the game is to say, look, quantum theory doesn't give you in general a reason for a specific outcome, but you find one. So you have to assume you find one. That's an absolute basic datum. And then you extend that assumption that we find the same one. So that's the answer to you. Okay. Carlo, I'm not sure. Here's the residual worry, and it might be just a philosophical worry, but it is a worry. Okay. Practically, we all come to agree. Sure, no problem. But put it this way. Maybe the only reason we agree is we're all in the same bubble. We can still imagine somebody outside of that bubble who doesn't agree. We can imagine it
in fact, that's just imagination, because if I'm right, then the process of decoherence confine us all to the same bubble, essentially. So it's not a practical concern. But if you apply a kind of Copernican move, there's nothing special about me. I could be the one inside Debbie's lab, and I would have experiences just of the kind that I have as it is. And my situation here is completely parallel to hers. So now I'm dismissing her observation report as irrelevant because she's now joined my bubble and can't even remember what she said, and there's no record of what she said now anyway. But maybe I'm in the same position, so I shouldn't take seriously my own report of my own outcome. It's not going to affect things practically, but it raises a position, a sort of concern that, you know, basically I'm not getting at what's real. I'm just getting at what's going to be enough to go ahead and continue doing science. That's the remaining worry there. Can I go, because I had a finger on this other point, or should you call a reply?
Go ahead.
Okay. This is really interesting. I mean, sometimes I feel myself drawn to some of the things that Bohr said, but I'm upset about all of this emphasis on experiments and observations and apparatus, because ultimately you want to be able to apply quantum theory to the big wide world outside the laboratory. And in that situation, of that application, it's not clear what the experimental context is. There is no experiment. So it can't be just that we restrict everything we say to stuff that makes sense in a particular experimental context. We have to make sense of what's going on when we apply quantum theory outside of any experimental context. So that's where I'm going to get off the Bohrian boat.
Wayne first, and then Czeslaw.
First of all, I'd like to make a comment about the Shure SM58 is one of my favorite mics. I use it at home. And the Shure SM58 is one of my favorite mics, and I use it at home. And the glorious thing about it is it has a very tight cardioid pattern. So if you're right ahead of it, if it's right in front of you, it picks up really well. The side, it's really terrible. Anyhow, this question is, I think, primarily for Richard, but also for the other two. There's these terms that come up, like context of evaluation, decoherence context, bubble, things like that. And I want to know better how to understand them. So this isn't a criticism. It's just I want to get clearer about what I'm supposed to take these things to be. And maybe I can what I want to get clear about, sharpen what I want to get clear about by making reference to the extended Wigner's friend example. So imagine you could do an experiment like that. So we've got a lab over here, and you've got certain variables decohering within it, and so there'll be facts about those. Another lab over here, there's certain variables decohering in there. Can I also now take the union of those two labs as a decoherence environment and all those variables to be ones that have definite values? And if so, the worry is that, like Richard, in one of your papers, you talk about consistent extensions of a decoherence environment. And my worry is that if you're going to give a coherent account of these Wigner's friend experiments, you're going to have to say that, in one lab, Alice has sees one result relative to one consistent extension, and a different result relative to another consistent extension. And then is that how the account goes, I guess, is my first question.
I'll let Richard respond, and then Czeslaw after Richard.
And Andrea, too, has a finger.
Right.
No. No. It's working? Good, okay. No, the extension to different contexts is as follows. The rule is, you have what defines a context is you're able to apply the Born rule legitimately in a context. And frequently that involves applying the Born rule to get joint probabilities. of what's going on in your lab and what's going on in somebody else's lab, even though the two labs are isolated. Okay? And you can make that extension in different ways. You have a definite experience in your lab, you record a definite result. There's no relativity, like relative to this context, I record one thing, and relative to that context, I record something else, right? But when you're considering how you extend your context to other labs, then you have to make a choice. And you're never going to be in a context in which all three, well, you may or may not. You can extend it differently depending on the exact experiment we're talking about. There'll be some cases when you can extend not just to a single lab, but to a third lab in a different sort of experiment, okay? But there's never going to be a case in which you can extend it to all the labs. You have to make a choice. And from your bubble perspective, the choice is dependent on which choice, what you say about what's going on in other labs depends on what choice you make. But nothing you say about what's going on in your lab is going to depend on that choice. So it's like you have to throw in your lot with some but not others. And how do you decide to do that? Well, if you're wise, you decide to do it on the basis of who you actually expect to come into communication with later. And if Alice is going to come into communication with Charlie, then she's going to say, okay, so I'm going to take Charlie's assignments to be my guide. If she's going to come into communication with Debbie, Debbie's the one whose assignments she's going to go with. But she can't do both at once in all cases. So there's no relativity of outcome in that sense. You're not really worried, Wayne.
Well, what if I don't know who I'm going to be in contact with and I want to make plans for either eventuality? I can't do it?
Jaslav? Maybe
I'm
you
not
can
answering
illuminate
this
that Wayne's question.
No, I want to go back to what Richard said, that we should go outside of experimental context, and I agree with this. Nevertheless, we need a concept of context, general, maybe decoherence context. And then the question, of course, if we go out of the lab scenario, well, how to define this? Is one qubit a context of the other qubit? No. Okay, so I would agree with this. And I think one technical way, I don't have a better insight, is to distinguish between what is context and not context, is the states of context are always orthogonal to each other. That's what allow then to, well, to connect with the situation, which doesn't necessarily need to be true, when there is somebody inside that context to communicate what she or he sees and make sense of it and maybe invent quantum theory. But there seems to me still to be done on identification of what is context. And now about objectivity. I'm just repeating myself, but I find really mind-boggling the situation that we can have, by some means, evidences that there are different contexts and that we maybe even have a laboratory situation in which there are same events happening like a measurement results. So we have evidences that there are measurements, and nevertheless, we are not allowed to assign any definite outcomes to these performed measurements because we will run into difficulties. That is, as you also said, that seems to weaken the notion of objectivity beyond what we know from Bell's theorem, although the technical proofs are very similar to that. So it's not just different perspectives of given objectivity out there. It's really beyond that. Yeah.
Andreas?
No, you agree with this, everything. I just wanted to bring this discussion because it's so fascinating for me.
Andrea's been waiting a while, so no? Sure. So Carlo had a finger? Carlo had a finger?
I agree with Czaslaw with the last thing Czaslaw said. And the answer that, Richard, you gave me is the way I hear it. It's, oh, well, if there are possible different contexts, then, of course, I can be Wigner Fred, not just Wigner when I'm in laboratory and see spin-up. And, oh my God, in some sense, this is not objectively true. Yeah, I think that's messages we have to bring home from quantum mechanics. And I think this is where completely Czaslaw and I agree on that. And I hear Czaslaw also. I mean, I listen carefully to what you said, your discussion about that. I mean, you may have a point. I mean, in a sense, my reaction to that was, let's go the way through. Okay, so the context is defined by a system. What is a fact with respect to me is not a fact with respect to a chair. And I don't see any challenge in the science on that. I don't see any challenge in the practice. I don't see any social challenge whatsoever. It doesn't mean that we have to vote for Trump tomorrow. I think that we can do science. In fact, not only we can do science, this is the result of doing science. And it's one of these wonderful things of science when it just takes out something that seemed very clearly obvious for us and just happened not to be obvious. Seemed to be that. So I wanted to go all the way through. All right, so there are facts in the world, but facts are relatively to context, but contexts are just the system involved in the fact. Now, those of you say, well, Carlo, you're going too far. A qubit is not sufficient to define a context. I've hesitated in this conversation because my reaction was always, then what? The only alternatives go all the way to the coherence, but that seems to me cheap for a number of reasons that I want to go into. Now, you said something in your presentation, which is the resources. Qubit has very little resources. It has, in some sense, one bit of result, one classical bit. Because if we don't want to attach the ontology to the state, we have to attach the ontology to the fact. So the only thing that a qubit can have is just one bit of a. So perhaps the facts we should talk about should take into account not only the property of the system that we view as a system observed, but also the property of the other system to have enough capacity of information for holding the information in some sense about, for instance, about which direction the speed is measured of the other. So I do see what you're pointing out. I'm not sure I see an exact solution. I do see the difficulty here, but this doesn't change what seems to me the main message of quantum theory. The main message of quantum theory is that a certain level of objectivity is just shown to be not there. Period. Like, you know, objectivity about simultaneity is not there. This is much stronger, of course, but that's my reading of the situation.
Good question here.
Yep. Hi. Sorry, I asked Farshid to raise his hand instead of me because I'm behind the camera. Anyhow, what I was meaning to ask is, Richard was quite fast to discard that first option for understanding context, and that was consciousness, right? Now, I'm not sure whether consciousness, like a phenomenon, is perhaps interesting enough, but all the other things that come with it seem to be quite important, like I don't know, freedom of choice to set up an experiment this way or that way. So also that seems like an important constituent of agency. Having only observers seems to me is not enough to sustain these relative facts. We need agents. So with all this in mind, I was just wondering why discard consciousness so easily? Or how do you account for these other things? Like, thanks.
Richard?
Yeah, I went very fast in dismissing that. There are people who think that's exactly what you should say to define a context. As far as I understand it, that's Hervé Schwien's view in Paris, and perhaps other Parisians who are more sympathetic to French philosophy than I am at the moment. But I don't think you need consciousness here. First of all, I want to physicalize the notion of a context, and that may be just a prejudice. But I think you don't need to appeal to consciousness to have a functioning concept of an agent which has intentional states, which we can call, perhaps with scare quotes, beliefs, if we're so inclined. And I think here I'm actually still on board with the QISS, despite their claimed, their alleged subjectivity. I think a QISS agent need not be conscious, in my understanding of cubism. But it has to be an agent, and you're right about that. So what does it take to be an agent? Well, that's rather an ill-defined question until you outline a number of abilities of such a thing. But I certainly have no problem with attributing agencies to other biological organisms besides humans, even those organisms whose consciousness is in doubt. I see no problem of extending it further to aliens, androids, really sophisticated, advanced artificial intelligence programs with connections to robotic machines. They could all be agents, maybe even groups, like not simply Charlie, but every lab assistant in Charlie's lab. They collectively could constitute a group agent. So I'm with you in needing something like agency. It might be very primitive, though, and it certainly doesn't, from my point of view, need to involve anything like consciousness. There has to be a record on which action could be taken minimally. To be a record is already to be something which I characterized intentionally. It's not just a lump of matter with a 0, 1, or 1 on it. It has to have a function and for an agent.
So we had a finger there, Dan, I think, and then Daniele afterwards.
Yeah, this is a relatively brief side remark, but connected to this issue. I don't know if it can be worked in any systematic way to any longer discussion, but with respect to the issue of the connection of consciousness to objectivity, there is a certain observation you can make that has some pull, I think, about thinking with respect to the issue of subjectivity. So insofar as consciousness is bound up with our ability to think thoughts that are answerable to the world, that are possibly true and possibly false, and insofar as the issue of wanting to represent as opposed to misrepresent the world, so to think thoughts truly when we could think them falsely, is bound up with the issue of objectivity. You might think you need thinkers for the question of objectivity to even be philosophically relevant. If you had a world without someone to possibly misrepresent it, then these issues might be less of issues.
Daniele, had a finger?
Yeah, just a brief comment. If I understand correctly, Charles' point, the point is that there are constraints or limitations to how much we can naturalize the observer. And that's fine. That raises the issue. I mean, the important point becomes what are such constraints and how we can characterize them. Otherwise, indeed, it becomes a bit pointless if we cannot start from there and say something more. And if I understood correctly, the key point is the amount of resources or maybe some form of measure of complexity that the observer has to have. And I think one can read it the other way around in relation to the issue about consciousness. It's also quite clear from the same line of reasoning that you don't need to go all the way to a conscious agent. You can have a milder, more naturalized notion of agency that only requires some degree of complexity, minimal degree of complexity.
And again, the point is which one, and the suggestion, a suggestion could be that part of the criteria could be whether the observer or naturalized agent is complex enough to support Bayesian probabilities. Because at the end of the day, when you have an assignment of a quantum state, that amounts to an assignment of probabilities, and then depending on which view on probabilities you want to adopt, that may place some constraints on what sort of observer agent you need to use, you need to include in the picture.
So Ravi had a finger?
Sorry, this doesn't mean that you have to go Bayesian, or that, it's just that if you want to go Bayesian, that may imply some constraints on your definition of agency.
Ravi had a finger first, and then.
Okay, thanks. So the mathematical facts that underlie these extended Wigner-Friend scenarios are the same facts as for Bell or Cauchy-Specker, as Čáslav pointed out in his talk. And so, and in the case of Cauchy-Specker, for example, the lesson we draw from, one lesson you can draw from the theorem is that the Bond rule itself doesn't care about which context you measure something in. The probabilities are not sensitive to that fact. But if you're trying to give a hidden variable account, you need to take into account the context in order not to run into logical contradictions, if you give that sort of account. Now, I'm trying to understand what's the analogous story here. And to the best of my ability, the story that I can find here is that quantum theory itself doesn't care about the Heisenberg cut. Like, you know, you can move the cut around and like the theory is consistent. However, if you're trying to give an account of what you observe when you fix a cut, and you're trying to reason across different Heisenberg cuts, then you need to care about the cuts you've made, even though the predictions of the theory don't care about the cut. So again, so it's an extra theoretic thing. It's not part of the, because when we talk about objectivity or talk about, you know, facts or their objectivity, that's not a statement within quantum theory. It's kind of like it's like an extra statement. We're not calling it an ontological model because it doesn't fit the standard description of the ontological models framework, but it's kind of morally, it feels the same to me. So I'm just wondering what, I don't know, maybe Čáslav or anyone else has to say about that. So.
I had a finger.
Richard had a finger first, and then we had a finger here, and then we had Čáslav with a finger, and then there's some new questions, I believe, on this side. But let's continue with this thread first. Yeah, go ahead, Richard.
Oh, thank you. Yeah, I actually don't think you need to have a sufficiently sophisticated agent for that agent to deploy the notion of probability. All the agent has to do is to record an outcome. The agent doesn't have to go on and use that outcome and several others as the basis for assignment of a quantum state and generate probabilities. So it's a more minimal notion of agent than that. Okay, that was all right.
Question here? We'll finger here. And then Čáslav.
First to Čáslav's point, well, it seems to me if you give an agent enough complexity, perhaps it'll just end up having consciousness. So that's one possibility that we don't know.
Can you repeat?
Yeah, so if you just make an agent complex enough, maybe that will just give rise to consciousness. So if you make it complex enough to be an agent, then it might just as well in process become a conscious being, and just emergently, right? Not by some other way. Anyhow, and to Richard's points about whether we need something fairly complex to understand probability. Well, I guess it depends on what is an outcome and where it is, so to say. If it's just in speaker's head, then we certainly need something a bit more complex, I would say, than if it's out there in the world, and then the observer just needs to record it. So yeah, that's it.
Yeah, I somehow share opinion with Richard. I don't feel the consciousness is important here, and I also don't think that very sophisticated agents are necessary. After all, we can replace this Wigner and Windex friend with just two machines that outputs results, and we should still be stunned by the no-go theorems. But there is something which is important, and I feel like it escapes, and this is definition of the context. Now, Daniela said a sufficient level of complexity. Yeah, certainly. However, this sounds as if this is a composite concept that you can reduce on more elementary ones, much in agreement with what Carlos says. But here is a problem. Like, if I go and say, look, this context is just a bunch of the qubits ordered in certain way, what can I say about them? Because we just learned that only meaningful statement about the single qubit is with respect to the context. It seems like very circular. So I'm not sure even that we can resolve this issue, that we can decompose context into something more elementary. And this brings me again to a discussion that we started in the last session, and I think it's relevant here. And it's about probabilities. Like, it seems the probabilities have probabilities are the, let's say, after we, usually in laboratory context, they are very clear what it is. Yeah, we perform the measurement, we get a new quality, a new outcome, something happened in the sense of the facts that are really new perceptions, clicks in detectors and so on. Now, if you want to remove this from the laboratory scenario, still being in the context, I could say, I guess we could still say, well, things happen relative to the context, and the context is large, whatever, decoherence. But if I want now to decompose context, then it's a circular, because the things doesn't happen in that sense on the level of single qubits. So that, I don't know the resolution of that, but at least I think I'm fine with this, that we don't do that. And we say, okay, there is a context, with respect to context, things happen, and at least not in that way try to decompose the context anymore.
Carlo had a finger, and then Daniele after Carlo, and then we had some separate questions here, but we'll continue with this current topic for now.
Well, first, I don't find interesting a science which is based on the idea of what happened in the world. It's some facts, maybe relative facts, that only happen if there is a conscious being or some sufficient level of somebody betting on the future. I don't find interesting this direction of understanding the world. I think that I want a science that makes sense, not just for a laboratory, but also for all the ways we understand quantum mechanics. We use quantum mechanics for what happened in the sun, and what happened at the early universe, what happened at supernova, and so on and so forth. I want to understand what happened there, totally irrespectively of every complex system, every conscious thing, every sufficient level. And I want to stress one point, to go to the origin of the notion of context, which is Bohr, of course, because it's the Bohr contextuality which comes about. And let's get back to his idea, because his idea, in my opinion, is incomplete, but it's the core, it's the right point. Namely, what are the facts? The facts are values that variables take. Well, actually, how do we describe facts? In quantum mechanics, in fact, the outcome of a measurement is always a value that we assign to a variable. And Bohr came out with the notion, the original notion of contextuality, number one, because there is no facts about position and momentum at the same time. So what Bohr was noticing is that the position of the particle he was dealing with doesn't exist by itself, it exists relative to the apparatus. So the notion of position is not something that pertains to the quantum system, it pertains to the couple quantum system apparatus. The notion of momentum, it pertains to the couple quantum system and a different kind of apparatus, where what matters is what kind of interaction between there is the apparatus and so it seems that the key message there is, look, the property of a system are not property of a system by itself, a property of a system relative to something else. And the context is simply this something else. Period. Where what matters is the way the two things interact and the something else. What seemed to be, in my opinion, we have learned after 100 years of applying quantum mechanics outside the laboratory, because that's the point. What we've learned enormously about quantum mechanics is that it's much more than what, it's not just preparation and measurement. It tells us why the sky is blue and why there are supernovas and why there are high-level elements in the universe. Is that it's not just a system and apparatus, seems to me, it's a system and another system. So that seems to me the core idea of contextuality. When we assign a variable doesn't describe how system is. It describes how system affect another system. So variables are profoundly relational to start with. A particle doesn't have a momentum, has a momentum also in the sense that when it interacts with the momentum interacting apparatus, that something happens. And has a position in the sense that when it interacts with the screen, which detects its position, so to say, something happens. So the contextuality is a property of the variables. So it seems what we have to change idea is not to go, oh my God, what is the context at a very high level. Just go back what we mean by a variable. A variable, what do we mean by a system? A system is characterized by its variables. What else? Okay, a system is just a set of variables. But these variables are not real, don't talk about the system. Talk about how the system interacts, the possible ways the system interacts with something else. That seems to me the core idea of relative fact. So then, what is a fact? A fact is a variable taking a value, which happens when the particle interacts with the apparatus, or a neutrino in the sun interacts with an atom of helium in the sun, and we use quantum mechanics to say what happened with which probability. So that's why I would like to reduce the notion of context down to its bare minimum, to its bones. And if one can go down to a qubit, maybe one wants something with enough information to pick up the direction of qubit, but not more than that, seems to me.
If I might interject a slight. So I don't disagree with what you said, but I think there's a part that you haven't emphasized. I think for Bohr, what's also very important. So I think like when Richard talks about an assessment context, I think that kind of gets to the idea that what needs to be possible is that you need to be able to communicate the results of your experiment. It's not only that you can give a quantum description of two systems in interaction with one another. You also need to be able to tell a story about in regards to the conditional probabilities that you observe, the relative frequencies that you observe, how those translate into a classical description to your colleagues, to so on and so forth. I think that's I don't take what you said to be to contradict that, but I think that's part that I think that needs to be emphasized vis-a-vis Bohr's thought in any case.
Right, but I mentioned Bohr not because I want to do an exegesis of Bohr, which everybody does its own way, and it's books about what Bohr talks. This is irrelevant because I think that in Bohr there is an idea which I find very interesting. Just that idea, and I think extremely good. It seems to just put the finger on the point which is confusing us about quantum mechanics. That's just to forget all the rest of Bohr, complementarity, whatever. The property of a thing is not property of that thing, are property of the way that thing interact with something else. So it's always properties, a cavallo in English, with two legs on two different systems. That's the point I wanted to make.
So there's two more fingers, I believe, and then we'll take a short break, and then we'll go on to some new questions. We had some full hands on this side of the room. So first, Daniele, and then Czaslaw, and then we'll take a short break.
Yeah, then first of all, let me stress that the point of my comment was to add one further level of questions to the statement by Carlo, with which I agree, that the core message of quantum mechanics is that we sort of know it from Bohr, but then the issue became to reduce as much as possible this notion of context, naturalize it as much as possible, and so on. The question is, how much is possible? And then I tie to what Czeslaw was saying. I mean, Czeslaw added a level of complication to the story. I want to stress another one, which is that it's not obvious at all that there is a bound that is absolute. Most likely, we are talking about a relative bound. So for a given quantum system you want to study, what can play the role of observer has to have a certain minimal level of complexity, resources, to be specified. So even that is a relational or contextual notion. There's no absolute bound out above which you start calling things agents or observers or something else.
Czeslaw?
No? No? Okay. Yeah, I fully agree with Daniela, and I think this is the kind of, for me, one of the most interesting questions to pinpoint how to define the context and what is the minimal resources for that, or at all, is it possible to define it or decompose in any possible way? But there is something, I think we agree all on the notions of relative facts and the notion of objectivity. I think this is fine. Now, I would like to pinpoint now on the difference. I think this is important. And this is the notion of how the probabilities arise in the first place. If we say the probabilities are defined relative due to context, and we say also that the context you cannot decompose all the way down, like one qubit is not the context to the other. Now, how then, in the view of equality among all the systems, doesn't matter whether they are small, big, context qubits, probabilities arise, in your view, Carlo, in the first place? How the probabilities, if you don't want to rely on the context, in the sense that we were speaking so far, not necessarily experimental context, but context with some certain decoherence, how the probabilities then arise in the first place, or are they at all?
Carly, do you want to quickly respond? And then we'll take a short break.
I don't know. I mean, I've been reading books about the meaning of probability. I've reading Wayne book, and every time I read a new book about probability, I change my mind about what's the foundation of probability. So one thing I learned from Wayne is that they're not alternative, they're different. So the way I view it, which is not as a philosopher of foundations of probability, but as a physicist, is that we happen, thanks to historical experience, to come out with a good theory, which seems to describe very well the world, which give us numbers which are probabilities. And we happen to make measurements that, when we repeat them, the frequencies approach these probabilities, so that I'm ready to bet that it's convenient for me to bet in a certain way. And therefore, I think that something in the world is such that this happens. So I gave you an answer which mixes Bayesianism, frequentism, intrinsic probability, how is propensities, all together. Now, which one I view as fundamental, I don't know. It's I'm not even sure this is the. Oh, that's not the question. So your question is so maybe I misunderstood. The theory, what quantum mechanics is for me, it's a way of computing amplitudes between relative facts. Let's say no relativity. Let's not make time here. Time is nothing. So there is time. Quantum mechanism, it's something that tells us that the world is such that facts happen in the world in a probabilistic way in this way. So every time I arbitrarily, as somebody was pointing there, choose a Heisenberg cat, the CUT, and I consider, I arbitrarily consider a system as a physical system to be described, and the rest are free interventions, free because there's a free agent, or free because there's wind pushing. The response of the system to the interventions is determined probabilistically by the. So maybe we're asking something else.
Well, let's continue this over the 5-minute break, and then we'll come back. All right. Okay.
The conducting so far. I have to apologize because I gave a wrong announcement before. I had an old version of the program. The information on the website is correct. So dinner is at 7. 7 we start with the drinks. 7:30 you will have food and so on. So this was done to give you time to relax and talk.
I can.
Yeah, go ahead.
I have a question. It is not clear to me in the relational interpretation which is the causal account for Bell inequality violation. That is, I have I have two measurements in two space-like separated. So I have two relative measurements, relative facts, space-like separated. But these two are correlated. So, which is the causal account of from a relational point of view? It is like many words that the causal account is, a local selection of the branches, or there is some kind of explicit non-locality in this. Obviously, it is not local in the sense of local causality because to violate it, the inequality, so it has to violate it. But I mean, apart from the local causality, there is some account that is not local in the sense of like in Bohmian, or it is more like many words.
I'll let Andrea answer.
Hi, Emanuele. This is a great question. Thanks for asking. And I think I don't have an answer for it, and I think I would want to hear what the others think as well. There's one sense in which people that share the same, I don't know, we were calling the coherence bubble, or I call them stability classes. Like the word that we observe obviously is Bell non-local. So even with the relational facts, we do have Bell non-locality in this consensus word, if you want to call it. Now, if there is a different account that is still local, I don't know. So that's one thing. And the second thing is, I mentioned it in my talk, is that Bell inequalities rest on the notion of absolute events. And if we take our absolute events, then there's no reason why there's no reason why we need to worry about locality, but then we don't even know what to talk about things that are distant. And I know here, for example, Pierre wrote an article on this. I don't know if he's thought more about it, obviously Carlo, but I think this question is still very much open. And I would want to hear also from people that think a lot about this, independent of relative facts.
Finger here.
Yeah, what I can say about how to understand Bell's theorem in context of relational quantum mechanics is that it depends what kind of explanation of Bell's theorem you're looking for. If you would call an explanation of Bell's theorem a way to think of it in a local way, and by a local way, I mean local in space-time, then this is not provided by relational quantum mechanics. So you have a true notion, you have indeed a deep notion of non-locality in relational quantum mechanics that you need to understand if you want to be comfortable with it, since it's indeed a bit against our intuition. Now, what relational quantum mechanics can be used for in understanding Bell's theorem is indeed trying to re-understand what is a beable, because in Bell's theorem, the notion of local causality that is introducing relies heavily on the notion of a beable. But what is a beable? So a beable is basically the basic elements of reality, the ontology that you have. And of course, depending on the interpretation that you take, the concrete content of what a beable is going to change. And so in a purely relational, in a relational context, it is of course not obvious what you want to call an element of reality. And if the beable is, and I think that there is a way, in a sense, to make sense of what would be a relational beable, and that would be basically a relative fact. And so there is a way to make sense of non-locality in a relational context, but this does not trivialize the result of Bell's theorem.
Are there any fingers on that? I got you. So if not, if there are no fingers, then I'll go to the next question, and that'll be Chris Bank.
Do I have to hold it? Okay. So I think this is a relatively minor point, but there was one thing that I thought was clear in Andrea's presentation about stability of stable and relative facts, that I'm curious whether it applies to the other points of view as well, which is that if that's a matter of degree, if it's a matter of the degree to which you can neglect interference terms, then you'd expect exactly the kind of contrast between the 2-qubit case and the full laboratory case, that you'd expect that there would be a kind of gradual development of context in which you can have more stable facts. And then in some, at either extreme, it will look very classical on one extreme and then very quantum on the other extreme. So I'm curious about whether that's right, first of all, that's a correct understanding, and whether the other discussions of a bubble or a context dependent also treat that as a matter of degree rather than a matter of kind.
Let Richard, then Czaslaw. Andrea, did you have a finger as well?
Yes, but
Okay.
so I just wanted to say what Chris said was correct, and maybe this will bring us back to the very first question that we were having, and also connected to Emily's concern, which I don't think was addressed in the end, is that like if I see the same decoherence as somebody else, it doesn't mean that we are sharing facts. It just means I can ignore the fact that their facts are not my facts to a certain extent and not lose my bets. And I think this applies to all of them, to all the things. And yes, the coherence is only a matter of degree. It's not a solution to this sharing of facts. That, in my understanding, I think also Carol's understanding, this comes from the direct interaction with the other context and the other system. But this still somehow doesn't really go all the way to what Emily would want, which is this, that we are seeing the same thing exactly, but now again, this might project us back into the earlier conversation, so I won't say anything more, or unless people want to talk about it.
I'll let Richard and Czaslaw respond to Chris.
Yeah, in my view, it is a matter of degree. And that's why I don't really like talk of Heisenberg cuts, because a cut is a very sharp thing, although I'm well aware that you can cut wherever you like within a certain range. Okay, my use of decoherence is different from the use of decoherence by the relational quantum mechanics people, because they use that to talk about this thing called stable facts. And there are some underlying relative facts, which is the ontological story. And the stable relative facts are a sort of a higher order notion which gets employed to help us to understand intersubjectivity, I think. But my use of decoherence certainly has a more crucial role in applications of quantum theory. And decoherence, of course, is not perfect. It's not. It lasts a long time. It's extremely efficient, but eventually, it gives out. And it's always approximate, although very good approximation in many circumstances. You can't expect decoherence to solve the measurement problem, right? It's not in the business of doing that, in my view. And indeed, I should say something even more surprising to some people. If you wholeheartedly pursue a view of the quantum state as not itself an element of physical reality, but take a more abstract view of what the quantum state is doing, then decoherence doesn't literally describe a physical process. It helps us to model physical processes, but it doesn't actually represent the evolution of any systems, because it just talks about quantum states and how they evolve. And if quantum states aren't telling you what's going on in the physical world directly, then these models don't tell you either. So from my point of view, the decoherence is something that entitles you to say things. And your degree of entitlement corresponds to the degree of decoherence. So given the sort of magnitudes we're talking about here, you're pretty darn entitled to make claims about the outcome of a quantum measurement, at least in the appropriate context. And that's all you need, okay?
Czaslaw?
Yeah, I know that this is semantics, but I think like we use the same word for different things, and I want to clarify for those that maybe not so close to this field. And that's when Andrea and Carlos talking about stable facts, I would say, for me, these are the facts. I don't need to say stable facts. They are facts, but they are within one bubble. Stability is relative to the bubble, and there are facts within one bubble. But what is surprising that even such stable facts with respect to a bubble are really just relative. There's that's surprising things. Now, when we talk about relative facts, I wouldn't even use the name facts because of what I said in my talk. These have a completely different nature than the stable facts. Like you cannot associate them. There's a probability of the basis. You cannot associate them with some statements. Then you can maybe associate with many statements at the same time. That's the last proposal from Emily. And so in that respect, if it is about 2 qubits, I would not call them facts, but they are called by Carlo relative facts. And those that are kind of stable, these are facts, but these are actually relative. That's very interesting.
Carlo had a finger, and then we'll go on to you next.
Yeah, I think this last exchange for me was very, very clarifying in the core of the discussion. And at the risk of repeating what Richard said, let me try to say how I view it. It started from a question of whether stable facts are a matter of degree, and Andrea said, yes, of course they're a matter of degree, because this was Chris' question, because the coherence is a matter of degree. It's more than that. The coherence is a relative fact. It's a relative fact in general sense. The coherence is relative to something, to the possibility of interacting, to the ignorance of something, to the. So let me take for 1 second relational quantum mechanics not as an interpretation of quantum mechanics, but just as a terminology, as a terminological definition of things. And I think as a terminology, we can all just for this 10 minutes agree on the terminology or using the terminology this way. Terminology is there, and I think it's coherent. And then the question is, how do we choose the ontology? And there are alternatives of choosing the ontology, because the interpretation of quantum mechanics is choosing an ontology. So saying, okay, I got it. We're talking about a world where this is what is out there in the world. So one possibility is to say, my ontology is the stable fact as defined in the paper by stable fact. So the ontology is there only when there is the coherence. Andrea and I have resist this choice for the reason that it's the ontology itself is a matter of degrees. And Richard has an answer to that, which is a deeply philosophical answer. And so the split is not about, in a sense, the interpretation of quantum mechanics, it's really about the philosophical attitude. So Richard's answer is right, but we're having propositions, and a proposition is true to the degree in which there is something that validates it, so we can agree about that. And this is a matter of degree. So, okay. The truth of quantum mechanics, the proposition of quantum mechanics, it's validated to some degree, better or worse, by the fact that there is the coherence, which is a matter of degree, that allows me to say, yes, the spin is up. And I think this is consistent and coherent and stays together, and it's fine. The philosophical instinct of several of people is, can I say something more? Can I increase my ontology a little bit more without going all the way to hidden variable, without going all the way to many worlds, to have slightly more realism, something that is not a matter of degree? One option is to say, remember, we have relational quantum mechanics as a language, to say, okay, there is a good definition of relative facts there. And remember, stable facts are relative facts. They're not non-relative facts, they're very relative facts. because they are a subset of relative facts, and because the fact of being stable, it's relative to something itself. So one option is, okay, let's take all the relative facts as a good ontology. It's a rich ontology. It's richer than, because it includes the things that the friend measures and then get immediately cancelled by the fact that Wigner measures something in another basis. So there's no memory of that. In the universe, there's no memory whatsoever of that relative fact there. But it's put in the ontology of relational quantum mechanics. So one of the richer ontology, and this is a matter of taste to some. To me, it sounded a great option. We have an option which is not hidden variable, it's not, there is a little teeny version of hidden variables, right? Because I'm saying, yeah, nothing of what friend does there, it's gonna affect, nothing of which particular outcome has friend seen can affect anything in the future because I measure something else. So it's lost forever, but I put it in my ontology, why? Because since I know that I myself is like a friend, this is what the Richard comment. I'm always a friend also. Every time I see something, there's somebody else that can be interference between me and the other branch. I want this to be in the ontology. Let's bring all the relative facts in. And that's the ontology of relational quantum mechanics, to which Jaslav say, okay, can we go in that direction without getting to the troubles to giving the status of facts to things which are too weak and too frail to like the interaction of two qubits, something like that. That's how I view the picture.
Question here.
Okay, I hope I will not derail the discussion because it was a general comment and it was a very nice discussion you're having. So I wanted to make a general comment. First of all, this is great. I'm enjoying it a lot. I have not thought deeply about this, but I wanted to say something that how to say, one of the points of doing this project is to mix together the communities, right? And I was your student, and I've been spending a lot of time with Jaslav lately. And there was a realization I made a few months ago that there's certain deep misunderstandings or where each other is coming from. So there are very strong convictions in loop quantum gravity, right? You said before you are whatever, fanatic or conservative or whatever. What he means by that is that I mean, one of the main, how to say, I don't want to say dogma, but convictions, basis of this program, loop quantum gravity, is that we don't touch quantum mechanics. We don't touch it. Take it as it is. And what we want is to see space-time, geometry, emerge from something. So what you care about is space-time. You've been thinking about that your whole life. And you're like, I want to see space-time coming out from something more fundamental, but I don't want to fiddle around with quantum mechanics because I don't see a reason to, and there's other motivations that have to do with other quantum gravity communities. Let's not get into it. Now, on the other side, they've been thinking about probabilities all their life. And they want to see probabilities coming out of something more fundamental. And this is really a deep misunderstanding because they do not understand why, for instance, you would write down a theory and you have some stuff called spin networks that have no meaning by themselves, but there's probabilities attached to them. And you can superpose them, and then they're like, wait a minute, what are these probabilities? It's a probability of what? Of what happening? What is the meaning you attach to them? So I just wanted to put it out as a general comment that maybe one thing that could be done with the communities is to think of whether it would be good to see both things emerge rather than keeping one in this case and trying to see the other emerge, to accept that maybe the point would be to have a framework where you have neither probabilities, you don't have quantum mechanics really, nor space-time, and you get one as a limit and the other as a limit, and then you see what is in between. Just as a general comment.
Any
I want to, I was observing this last discussion between Carlo and Czaslaw, and somehow I come to this understanding, please correct me if it's wrong, but it seems to me, and I did exactly what Carlo said, is yes, there is this element
Can you
of
speak a little bit more into the
there is this element of hidden variables. I think this is very important, actually. And there's this issue about falling into the trap. And it appears to me now, my understanding is correct about this whole idea of relative facts, is that the following picture is somehow suggested. You have a hidden variable picture. You have these facts that you can think in some absolute sense if you like. But it is relative to someone or relative to a certain perspective that certain properties would hold. And these properties are those that we require in no-go theorems, like, for instance, in Bell or Cohen-Specker. And it seems to me that this is the picture that emerges. You do have these facts in some absolute sense. It is just these properties that enter in our no-go theorems that hold relatively or relationally. Does that make sense to?
Czaslaw had a finger?
This is exactly what I wanted to say at the end of the last session, but we moved on, is that if you have this idea of having probabilities independent of the notion of the context, like because you want to have things happening probabilistically on the level between 1, 2 qubits, and you also want to be in agreement with the idea that you can recover observed probabilities when you put the context, then it sounds very much that you will get in trouble with the no-go theorems. Because this is exactly what is no-go theorem says it's impossible. You should not be able to define probabilities independently of the context, such that they are still in agreement with when you put the context and measure them, you get quantum mechanical probabilities. And this, for me, is the trouble of how to make this ontological picture independent of good context. And I'm not talking about measurement context, I'm talking about richer context, where the measurement context is a special case.
Yeah. I mean, I'm very glad that I hear this discussion here because in the 90s, when I was doing my PhD, the whole idea of bringing the context explicitly into being was complete taboo in quantum foundations. It was complete taboo, and if you even dare to mention it, you were, I don't know what you were. So, but given that one now allows the context to be an explicit part and determine to some extent what you assign as facts, then there is a whole bunch of results from the 90s that you can actually assign variables to this context explicitly and obtain a fully deterministic model without even ever assigning variables to your state. That's not at all necessary. You just take the quantum state, you put a variable in the context, and you get very simple, elegant, deterministic models which determine your measurement outcomes. And there's also even ways to bypass in that way Bell's theorem and the issue of locality there. So if this, in a way, in a very simple way, saves determinism for everybody who wants it. And I don't think these results are known because they're from the 90s and nobody at the time cared anything about it. So actually, my entire PhD was about that.
Yeah, so I would just like to say that I'm hearing this discussion for a while now, but it's not really clearing up the quantum measurement, not solving the quantum measurement problem in my mind at least. Because you see, so of course, when you have 2 qubits, of course, you can get all sorts of bases, as Czaslaw was pointing out in his talk. But even when you have, like as Czaslaw was saying, a more complex system, say a large spin or something showing a direction, or a more macroscopic system, again, it's you know, in the Schmidt decomposition sense, it's again another qubit, right? So. And no matter how large you get, you always can have another observer outside to whom it is just 2 qubits. So in some sense, I mean, I don't know whether we can make a meaning. I mean, either of these two interpretations is not making, not seeming to me like solving the measurement problem. But yeah.
Emily?
I just have to react on Bob's proposal. I mean, this is possible, but I mean, you will agree this is just superdeterminism where the lambda of the context is strangely correlated with the property of the particles just to violate Bell inequalities with 2 square root of 2.
Go ahead, Emily.
Yeah, to your question, the solution that Carlo and I offered in our recent paper, and I don't know if this totally succeeds, but the idea is that, yes, with a sort of single qubit interaction, you have a whole range of bases and you don't have a preferred basis. But when you combine that with decoherence, what decoherence does is that it selects a preferred basis. So because you're at the level of individual qubits, you've selected definite facts in a range of bases. When you add the decoherence basis, that then selects the fact in a single basis, and that's supposed to be kind of the foundation of how a measurement problem gets solved. And that probably needs further development, but that's the basic idea, I think.
Yeah, please.
Yeah, so I know, I mean, that kind of argument has been there from like Zurek and others for a while, like a common basis, and it's true because of locality of interactions. We mainly interact in position basis, so those all are right. But what I'm telling is that you can always, I mean, whenever you have a qubit entangled with whatever, however large a microscopic system or complex system, it's always, because Schmidt decomposition is just an effective qubit, the large one. So someone sitting just outside it will always, be able to find all these correlations. Yeah.
But I mean, you only need the value to become definite relative to the large system. It doesn't need to be relative definite to the person outside. What's enough is that as long as, to solve the measurement problem in this context, what you need is that values become definite and single valued relative to large systems like our brain. So it doesn't matter if from some other observer they don't have that definite value.
Carlo had a finger?
I'm going to try something just in the spirit of discussion. There's something disturbing in thinking the qubit is an observer. But let's take for a moment relational quantum mechanics seriously. Then you should not think in terms of a qubit with its state, because that was the point one. The point one was when talking about nature, talks about variable that has some value. That's what nature is about, and interactions, Hamiltonians between these. So I'm talking to a community of quantum information, so I cannot tell you don't think in terms of qubits, of course, because that's the way you think about the world. It's perfectly okay, of course. But when you measure a qubit, you're not measuring the qubit, of course. You're measuring the spin in one direction. You're measuring sigma x, or you're measuring sigma y. You measure sigma z. So perhaps reformulating the objection in terms of measuring sigma y, measuring sigma z, measuring sigma x in a context in which the Hamiltonian is this one, might weaken this intuition of, wait a moment, in which sense an entangled state of two qubits, it's one having information about the other one. Because an entangled state, it's from the relation from the perspective of relational quantum mechanics, is not something that's the qubits. An entangled state, it's something that pertains to the fact that the third system has interacted with a couple of qubits and has been affected in a certain way, which is measuring one variable of the two qubits together. So the confusion is like confusion. It's exactly the confusion, which is what is the state of the friend when Wigner measures something which is not in the basis of the measurement basis inside. I'm not saying anything precise, not saying anything definitive in any sense, but I want to challenge this idea that I write states, quantum states, I think in terms of qubits which are quantum states, and I find something in tension with relational quantum mechanics. Of course you are, because you're talking in terms of states. And the entire message of relational quantum mechanics was just not think in terms of, well, think in terms of states when you want to do calculation and when you think of what happened in the laboratory, of course. But if you want an ontology, don't think in terms of states. It's doesn't mean to be convincing. It means to be evocative.
So Bob Cook, you had a finger.
So yeah, I want to make clear that what I'm talking about is not at all superdeterminism. You still got complete freedom of picking your measurements. So you can do this sort of model where you put variables in the context, you retain your freedom to pick your measurements, free will, and still you get a deterministic model. So these models exist. I think the only time they ever showed up in a paper out of the 90s was a paper by Terry Rudolph and Nicholas Harrington, where they went through a whole range of ontological models. And this was one of them. So I think it's worth for the people who are interested in this to actually go back to that work.
Richard, did you have a full hand up before? Yeah, okay. Richard has a new question.
Yeah, this is in response to some things that Carlo's been saying, but I think it deserves a hand. You talked about choosing an ontology, and part of my motivation in developing a view of quantum theory is to have as little ontology as possible. Specifically, taking quantum theory itself, not to provide us with an ontology by way of quantum states, for example. But that's not the ontology you were talking about. You were talking about ontology of facts, or in your case, relative facts. Okay. So in this context, you keep saying that your relative facts are relative to a system. But if we just leave it at that, then a system that has never interacted with another system, they're still relative facts. And yet you deny that. So there has to be more to it than that. There has to be an interaction. Okay. But then if there has to be an interaction, then you have to tell us what kind of interaction is going to give rise to what kind of relative facts. And that's where some of the things that Czeslav's been saying become important. But let's leave that issue aside for the moment and consider the case where I am Vigna outside my friend's laboratory. And I have a certain local decoherence environment which doesn't include what's going on inside my friend's laboratory. So in that context, I can't directly say anything about the outcome of my friend. But I can still, in thought, enter my friend's laboratory, not physically, but in thought. If I were inside that laboratory, would I experience an outcome? And I can say yes. So there's a sense in which I have and a sense in which I have not added something to my ontology. The sense in which I have not is that for me, unless I enter the laboratory, this has no significance. And so for me, I'm better off denying that there's an outcome. But in thought, I can think counterfactually, yeah, but my friend, I could be in the laboratory instead of my friend. And then I would experience an outcome. And I can trace out a series of inferences from that. And they will all be, as it were, counterfactual inferences. But I can add to my counterfactual ontology. And all that stuff is of considerable interest to me. But it's not sort of full-fledged ontology, the ontology that I'm entitled to indulge in outside my laboratory. That's the point I intended to make.
So I'll give either Andrea or Carlo the opportunity to answer. Or Carlo, whoever. Yep. Or who wants to answer? I mean,
he asked first.
I know, but I'll give the opportunity to answer, and then you're next.
I agree with what you said. It's in this sense that facts are relative. So you cannot combine them in a common. If you combine, that's also the point. If you combine them in assigning probability to all facts, then you get a contradiction. I'm perfectly aware of that. So it's I don't know how to articulate exactly that. You want to say this is not an ontology because of that. Sorry.
Well, is it an ontology? What is it to be an ontology? It's to believe that something exists, I suppose. What I have to say is it exists relatively. It doesn't exist relative to my context, but it does exist relative to my friend's context. What do I do with that? Well, one thing I do with it is to reason hypothetically. Were I to enter the laboratory, then I would then sort of merge context with my friend in such a way that it would be a good idea to add my friend's outcome to my sort of full-blown ontology. But that's still a subjunctive statement. It's not a statement that tells me, actually, it's part of my ontology right now. But it gives use to that kind of subjunctive ontology. We're talking about subjunctive ontologies, but that's what I end up doing.
So Czeslaw had a finger. I'll give Czeslaw the opportunity to have a comment, and then there's a question here and a question there.
Yeah, it's about refining, I think, relative facts. In the relational quantum mechanics, interaction seems to be important for establishing relative facts between systems. It seems to me that this is maybe necessary but not sufficient. And the reason is that usually in the lab situation, you distinguish three types of interactions. And they all end up with the three different states, and not only the states, but also in the facts. And here is an example. And this is very usually students ask, well, if the photon you sent through the beam splitter, why it isn't entangled, or is it entangled with the beam splitter? And the answer is, well, for the normal beam splitters, it doesn't get entangled or very, very weakly entangled because, well, the kick, the beam splitter experience from the photon is much smaller than the momentum uncertainty of the beam splitter. So they don't get entangled. That's what we explain as a unitary evolution of the photon, like no interaction. We effectively describe no interaction, although there were interaction between. So the states is not entangled between the a photon and the beam splitter, although there was interaction. Okay, then you go into, and that's what Marcus Aspelman is doing. You create smaller and smaller beam splitters and smaller and smaller. At some point, you reach the limit in which they do get entangled. So there is interaction. Now they are entangled. That's a completely different situation. That's probably the situation which one, maybe in relational quantum mechanics, would say the photon knows about the beam splitter and the other way around. But both cases of interactions, they're very different. And then there is a third thing, is that when the photon comes to the photodiode and get avalanched and you hear the click, that's what we call context measurement. I mean, the whole is the context, but it's the final measurement. In this case, usually you don't even describe this from outside. You say the state up there. This is also interaction of the photon in the photodetector, but it's yet the third type of the state and different from the first two. Only if you purify this type, the last type, then there seems to be seemingly same states between the second case, the beam splitter, small beam splitter and the photon, and the last case, when you purify measurement, the photon and the photodetector. And I say seemingly, because when you write down this state, you write it in entangled state, but the state of the photodetector has many, many degrees of freedom. It's virtually irreversible process where the one with the small beam splitter and the photon is reversible. So what I want to say with this, that it seems to me that one should refine then interaction if one wants to go with the relative facts, and this is still missing to me.
So we had a question here.
Yes, I just wanted to, again, to comment just in relation to what Carlos said again in this discussion about building the ontology. Somehow I have to admit that I'm having some hard time actually grasping this idea of how you kind of forbid the coexistence of these different relative facts because they are just defined relatively to different contexts. It appears to me there's nothing forbids us to just accept their togetherness, simultaneous coexistence as such. Maybe this depends on what we mean by existence, but you say that this leads to contradiction, but it leads to contradiction with certain assumptions. And so it seems to me that maybe one lesson or potential way is what I said earlier, that maybe the lesson is that yes, maybe there are facts, maybe all these variables are there, they exist in some sense. It could be relative to different potential observers. It's just that once you choose one such potential, well, context or whatever that gives us consistent story, then you recover the nice properties that we're used to, like node signaling and etc. So is that? I would like to know what Carlo thinks about it. Is that how do you understand this? What you said that somehow the other facts are that you cannot put them together. Is that the sense in which you cannot put them together, or do you think it's a deeper sense in which they do not coexist, or reality is somehow relative? Or
so I'll invite Carlo to respond, but I'll ask, please keep it brief because there are two more questions in the queue. There's one here and one there.
Should I go? Yeah.
Carlo, please respond. You prefer to go through the queue first? Oh, no, let's let Carlo respond to the direct question to him, and then we'll go. But if we can try to keep it brief if possible, then we'll end with the other remaining questions.
Well, I want to say first of all that the kind of thing that Chazar is pointing out, the kind of things that Yuong and Richard pointing out, are in completely different directions in a sense. In a sense, in the opposite directions, because the kind of issues that you're raising are exactly the kind of issues that don't depend on how much you want to bring down your ontology to finer and finer things. It's independent of that. While the kind of issues that Chazar is saying was this notion of that facts happen when there is an interaction is just too weak in a sense. It's not well defined. When you go into the concrete, what we call measurement is just only one variable which is picked out. And the interaction, which one is a variable picked up generically, and when it happened, how it happened. So I see it to unrelated set of problems. So regarding to the kind of issues that you're, I think that's the kind of question that you're raising is that accepting that the world is like that is accepting that facts are relative. But facts are relative in a strong sense. I give you my intuition. Also, I'm tired and maybe I start saying stupid things, but there's one way of viewing relational quantum mechanics. Again, this doesn't have to go all the way down to the microfacts. It's very simple. So Copenhagen quantum mechanics is correct when I'm the observer, and Copenhagen quantum mechanics is correct when you're the observer. And if I take everything I can say about the world that I can say about the world on the basis of my observations, my measurement background, makes a perfect consistent world. Yours as well, perfectly consistent world. You and I can communicate. I can ask you what you have measured. If we measure something the same basis, we measure the same basis, no problem. If we share a common recurrence invariance, no problem at all. We always have the same common basis, so we just make a list of facts of the world period and forget about all this mess. But if we don't have a common recurrent invariant, then the world as seen by me and the world as seen by you cannot be put together, not even in the sense of let's make the space of all possible outcome what you said and what I said and see the probability of all things together. It doesn't work. So in that sense, the facts are relative in a strong sense, namely, and that I don't see anything contradictory into that. As a world of respect to the world. Do I want to put it together in some sense because I really, really, really want to say that there is something outside there? Fine, I can do that. I go many world. Many world is consistent, has its own problem, mess of problems. I don't find it anything useful in doing that because it seems to me that the deep message of quantum mechanics is lost in if I go many worlds. The deep message being exactly that there is this relativity. When we say the spin is up, we mean relative is up in one context, one whatever you want to put it, or relative to me, or relative to some me as a physical set of variables, because system is just a set of variables. So any resistance against that is exactly the resistance for what seems to me, what I would say, the excessive realistic. There's some version of realism that is challenged by that. And it is challenged. It's a fact. It's like saying, no, but to me, and then that means this controversial, it's the same thing that saying, no, come on. I mean, special relativity cannot be right because, of course, something is happening on Andromeda right now. There should be a meaning of simultaneity because that's the way the world is. And I think the world can be in a way which there's a world for me, a world for you, which is overlap enormously, which have the same rules, which we can share, we can talk about, we can do science, but doesn't have to be. I don't need to. If you're the friend, I don't need to make. I cannot make the argument. If I see this, you can either see that and all say that and blah 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 blah, and I get a contradiction.
So there are.
I stop here because I didn't go rambling after that.
So let's try and keep the remaining questions brief. There are two questions. I believe you were first, and then we'll go here. And there's also a final comment that I'll stay for last, an anonymous one.
Yeah, it is a comment. There are many questions which are asked, many comments, and sometimes it's difficult for me to follow exactly the line of the logical discussion. But I think part of the confusion that exists is due to the way we use the word of a fact. And I think that it is used in all the sentences which have been said, it is used in slightly different meanings sometimes, but these slight differences can explain part of confusion. Sometimes we use the term of a fact to describe the interaction that happens between two systems. And sometimes we use the term of fact to describe the correlation that persists as a result of the interaction in between. And sometimes we use the term of fact to describe the value that describes this correlation, or this interaction. And of course, all these meanings are linked to one another. And also, hopefully, when we talk of a stable fact, what we are doing precisely is establishing a correspondence between two different relative facts, and we are saying, in a sense, they are all the same. And that's the way we have a consistent picture of the world. And I think, to give an example of how this remark could help understanding what a fact really is, I'm thinking of your example, Czaslaw, when you consider an untangled state, and you say, well, I have up plus down, but I can change the basis, and I describe the same untangled state in a different way. And so where is the fact if I have this freedom to choose the basis? But of course, if you change the basis with a unitary transformation on one of the two Hilbert space, to get the same untangled state as a whole, you need to adapt the other basis for the other system in a reversed way, so that what remains, what is invariant in this transformation is only the correlation, that you have a correlation, and writing the entangled state in a particular basis, saying it's up plus down, is in a sense misleading, because it is referring to a basis, a notion of up, a notion of down, which is not intrinsic to the correlation that exists between the two systems. The correlation between the two qubits, meaning right? Okay. 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 What I mean, the way I'm thinking of this example is, I think, in close connection to what is done in gauge theory, meaning we have different ways to describe my states, and all these ways are related by some transformations, but the invariant thing that I want to call a fact is what really matters for my ontology.
So I don't mean to cut it off, but let's save the response and discussion for after the conference, and we'll end with the last in-person comment here.
Okay. Yeah. So I quite like the example that Kaslav brought out of this light hitting the mirror. But so ideal would be to go from the second case from his second case to his third case. And I think that's where I don't see how it will be possible, because the time or how much leakage into the environment makes a mirror displace one way or other, like a photo detector. That's not clear, because all interactions are continuous in time, and they will. So at what point, like after how much orthogonality of the things interacting with the measured system, or how much leakage into environment you call like that's it, my measurement, I hear the click. That's not clear. That's what I'm saying.
So I'll have to leave it at that. And we have one more anonymous comment, which I'll just read out. And the comment reads, "This is a fantastic conference. Thanks, Francesco." And thanks, everyone.